Welcome to notes number 3 on solving systems of equations using the elimination method. So we've seen the graphing method and we've done the substitution method. So this time we're going to take a look at another algebraic method for solving equations. Sometimes it's not convenient to solve for a variable. So for example, in this case, we've got these two equations here, 3y equals 2x minus 1 and 5y plus 2x equals 25. In either case, for either equation, there isn't a variable that's convenient to solve for, because no matter which variable I pick, I'm going to end up with fractional coefficients somewhere. So sometimes there's another method that might be more convenient that will also give you the correct answer. So this is called the elimination method. And the idea behind the elimination method is that we're going to eliminate one of the variables. Okay? So the first step here, I'm sorry, this says step 7 because it's a continuation of the previous list. But basically, in the first thing we're going to do here it says write each equation in the same form. In other words, we want to line up the variables. So notice how in the first equation the y is by itself on the left-hand side and x is on the right, whereas in the second equation x and y are together on the left side. So it doesn't matter which one you pick, but I'm going to rearrange one of them so it lines up with the other. So I'm going to pick the first equation here, 3y equals 2x minus 1, and I'm going to subtract 2x from both sides so that it looks like the same form, the same order as the other equation. So when I do that, I'm going to get 3y minus 2x is equal to negative 1. Okay, so all I did was rearrange my terms. Now I'm going to line up my other equation right below it so I can compare them and see what's going on. And my other equation says 5y plus 2x equals 25. So notice how my y's are lined up here, my x's are lined up one above the other, the equal sign is lined up, and the constant is lined up. So everything is in the same order. Now, here I want you to observe, if the coefficients are the same, but opposite signs, that's a very good thing. Because notice how my x coefficient, one has a negative 2x and the other has a positive 2x. So now, if I add my two equations together, I'm going to add these two equations together because they're equal quantities. So when I add my two equations together, here I'm going to get 3y plus 5y is 8y. Negative 2x plus 2x is 0. So they cancel each other out, equals, and on the right side I'm going to get 24. So this is exactly what I was hoping for. You line up your variables, and if they're exactly the same, opposite, they will cancel with each other. So now I've got a much simpler equation with only one variable. It just says 8y equals 24. Well, this is very easy to solve. 8y equals 24. I divide both sides by 8, and y equals 3. Okay, so by eliminating one of the variables, it makes it much easier to solve for y. Now that I know what y is, I simply substitute that into either equation. It doesn't make any difference. If I choose the equation 3y equals 2x minus 1, I simply substitute 3 in place of y. 3 times 3 equals 2x minus 1, and I solve. 9 equals 2x minus 1. I add 1 to both sides. I'm going to get 10 equals 2x. I divide both sides by 2. I'm going to get x equals 5. Okay, so now I can just write my answer. I can either write like this, x equals 5, y equals 3, or you can write it in the form of a coordinate, 5, 3, with the parentheses. Either way is acceptable. And as before, once you have your solution, you can check that just by going back to the original form of both equations, the one you didn't modify. So the first one was 3y equals 2x minus 1. I'm going to substitute 5 in place of x and 3 in place of y. And check to see if the values make my equation true. So here on the left side I have 9, On the right side, I have 10 minus 1, which is also 9. So it works in that equation. And then I go back to my other equation in its original form, and I do the same thing. 5 times 3 plus 2 times 5, hopefully will equal 25. Here I've got 15 plus 10, and 15 plus 10 equals 25. So 25 equals 25. So the check is the same as all the other checks we've ever done. So the idea behind elimination is you line up the variables, and hopefully something will cancel. So let's try one of the examples on the next page. Okay, so let's take a look at example number 2 on the back. In example number 2, I don't have to rearrange either of the equations because they're already lined up. The x's are lined up one above the other, the y's are lined up, the equal sign is lined up, and so are the constants. So that's all set. But right now, if I add these two equations together, nothing will cancel. I'll get 2x plus 2x equals 4x. 3y minus 5y will give me negative 2y equals 14. And that's not helpful. Now I have a third equation with two variables. So what I'm going to do is I'm going to multiply one or both equations by something so that the variables will cancel. Now, it turns out that my x's have the same coefficient. So if I multiply the second equation by negative 1, and I have to do it to both sides, then I'm going to get negative 2x plus 5y is equal to negative 3. Now when I line up my equations, the top equation is 2x plus 3y equals 11. Now when I line them up and I add them together, I'm going to add my two equations together. My x's are going to cancel. 2x minus 2x is 0. So all I will have left is 8y equals 8. Very simple equation. My x's canceled. I don't have to worry about them anymore. I divide both sides by 8, and y equals 1. Now I can substitute that 1 in either equation. It doesn't really matter. So I can do I'm going to use the first equation, 2x plus 3 times 1, because y is going to equal 1, equals 11. So I have 2x plus 3 equals 11. I'm going to subtract 3 from both sides. 2x equals 8. Divide by 2, x equals 4. So there's my solution. X equals 4, y equals 1. As a coordinate, I can write it as 4, 1. So if I had graphed those two lines on the coordinate axes, those two lines would intersect at the point 4, 1. Okay? So press pause now. Try examples 1, 3, and 4, and then you can restart the video to check your answer. Okay, so let's check your answers. In question number 1, the solution should have been 2, 2. And I showed my work here. If you need to press pause to look at it, please do so. Then for question number 3, the solution should have been 10, 0. X equals 10, y equals 0. And then on question 4, the solution is 2, negative 3. Again, if you have some trouble, press pause, read over the work. Please make note of any questions you may have, and we can talk about it in class. Thank you very much.